Computers need to do arithmetic to be useful. But how do they actually multiply and divide using just ones and twos? It's simpler than you think, but easy to mess up too. Today I'll show you how you can do binary multiplication and division yourself, and point out the common mistakes to avoid. I'm Oliver, a computer science student in my final semester. When I first started, binary numbers confused me. Over time, I figured them out, and now I want to help others avoid that same confusion. This channel is where I break down foundational computer science topics in a way that I wish I had when I was starting out. If you're still unfamiliar with binary numbers, binary addition, and negative binary numbers, I suggest watching my previous videos on those topics, as you will know some of the concepts from those videos in order to do binary multiplication and division. By the end of this video, you'll be able to do multiplications like these and divisions like these by yourself with binary numbers. Let's get started. So I'm going to start off with binary multiplication. I will go through an example, but this is essentially like multiplication that you learned in school, just a bit easier, as instead of having digits from 0 to 9, you only have digits from 0 to 1. I'll first go through an example of this multiplication here in decimal, and then do the same one in binary. So you see the result is the same, but also the way you do it is very similar. So starting off, here we have our multiplication, 5 times 13. And what we would do is, starting with the longer number, we would start with the lowest value number, which here would be a 3. And we would multiply this with the number we have up here, the second multiplicative. In our case, this would be then 3 times 5, and this would be 15. So we would write 15 down here, and then we would move on to the next value. So the next highest value is this 1, which has the value 10. So this is in a tenor position, so this 1 means 10. And then our next multiplication is 1 times 5, but because this 1 is actually a 10, it would be 10 times 5. But in our case, what we would just do is we would do this multiplication, but then because this is in the second position, we would write it 1 unit to the left. So where we started writing our 15 from the right in this position, we would start writing in the second position for the next number. So 1 times 5 would be 5, and we would write our 5 here, and then we would fill the positions up until this first position with zeros. And this would be the same as multiplying 10 times 5. So our result is 50 here. And since this was the highest valued number we have, we would now add these. So it would be 15 times 50, and our result would be 65. So the result of the multiplication 5 times 13 is 65. Now we're going to move on to binary, and these are the same numbers. If you want, or rather I suggest that you stop the video and convert these numbers to verify that this equation is true. Once you've done that, we'll move on. And we're going to do the multiplication exactly the same way as before. This time, the only difference being that we only have zeros and ones. So starting with the bottom numbers, lowest position, this is 1 times this number. And if you remember, every number times 1 is just that original number. So we would just write this number again. And then we would move on to the next position. So the next position is a 0. We would not have to write this down, but to make sure our alignment is correct, I will. And we would just write zeros for all of these 4 positions. This is an optional step, but it's very useful when you're starting off to see where you're making your mistakes, if any. So here, again, we would fill up with zeros to make it formally correct. However, you can also leave it and just in the addition then consider that step. So moving on to the next position, we have our 1 here. Our 1 means that we're multiplying this, so we're not just writing zeros, but we're writing the same number. And again, we're shifting 1 to the left, as we've done here before, and then filling up with a 0. So now we will be writing this number right here, and then fill it up with zeros. Now, one more number is left, and this is this 1. And again, we write the same number we have before, just shifted 1 to the left, and fill it up with zeros. Now, as we've done before in the decimal example, we would add all of these numbers and see what result we get. So we have got our result here, and now we will quickly convert this. I will do this the quick way, and I suggest you convert this as well as an exercise. So our result will be 1 times 64, and then plus these would just be zeros, so I'll just write them like this. And our last value would be a 1. So it's 64 plus 1, which is 65. And this is equal to our result here. All right, now that we've seen the multiplication, we'll move on to the division. Again, I will have an example here. In this case, we'll have the numbers 5 and 10. And we'll do this division in decimal first, and then we'll move on to do it in binary as well. So starting off with decimal, the division 10 divided by 5. Here we're going to do long division, and we will be applying the same principle in binary as well. But starting off with a decimal example, first what we would do is we would look at the highest value bit here. We would see whether the divisor is larger or smaller than the number we have here. Because 1 is smaller than 5, we would not divide in this case, and we would just write a 0 up here. Then we would multiply this 0 with this 5 we have here and add the number down here. So 0 times 5 is 0, and we would have the 0 here. We would subtract this off our 1, so off this value up here that we have, and we will write the result down here. What we will get is 1 minus 0, which is just 1, so nothing new. But now we would go to the next value. So we have the first one of this 10 and then the 0. So we would take this 0 and pull it down here. So now we would have 1, 0. And now we would repeat the process, this time checking whether this whole number is smaller or equal to this number. Because we know that 10 is greater than 5, we can now do our simple division. So we know that there are up to 2 5s in 10. So because 2 times 5 is 10, we can say there will be a 2 up here. Again, we will multiply this 2 times 5 and then write it here. And 2 times 5 is 10, as we've seen before. So we'll write 10 here and again subtract this. Now, 10 minus 10 is just 0. And since we don't have any further values up here, we know that we've reached the end. So our result of 10 divided by 5 is 2. Okay, now coming to the binary example, this one will work exactly the same way in that first we check whether our number here is larger or equal to the first number here. We will align it by the number of bits we have in our divisor. So here it is 3. So we will check against these 3 numbers. In our previous case, we only had 1 position and therefore only checked for the first position here. But now checking again, 101 and here 101. It's exactly the same number, so we know that it fits. And that means it's exactly 1 times that number. So we'll write 1 up here. We will multiply again by this number here, which is just itself. So we will write it underneath and subtract it. So you see it's already a lot easier because you only have the numbers 0 and 1 to worry about. Then you do this subtraction, which, because it's the same number, just yields 0. And again, you pull down this number up here and it comes here. Now, the number we have is 0, and we see that 101 is larger than 0. So instead of writing a 1 up here, we'll write a 0. And 0, again, we multiply with this number here, but 0 times anything is 0, so we will just have another 0 here and subtract it from 0, which is also, again, 0. And because we are in our last position, so there's no further numbers to pull down, we end our division, and the result is 1, 0. And if you're already familiar with binary numbers, 1, 0 is actually just 2 in decimal, which is also the same result we got here for our decimals division. Now, in this case, it was a lot easier to get a result because the division only included 1 subtraction here, but say we had something a bit more difficult, like 13 and 5. So these numbers don't divide, and we will end up with the rest, which I'll show in a second. Okay, I have written down this division. So we will divide 13 by 5. Again, we're gonna align these 3 numbers with these ones. And we see that 101 is smaller than 110. And this means that we can write a 1 up here. again, we will multiply this and this. So we get minus 1, 0, 1. And doing this subtraction, we see we'll need to borrow this 1. So here we have a 2 then. Subtract, get 1. And then here we have a 0, so 0, and here's 0. Now we pull down this 1 once more. So we have 0, 0, 1, 1. And now we check again. Is this number larger or smaller than this number? In our case, we have that it is larger than this number. And for this reason, we will write a 0 here. Again, multiply this 0 by this. We get 0. So we subtract 0 from here. And our result is again 1, 1. And because we don't have anything to pull down, we finish the division here. And the result is, so 1, 1, 0, 1 divided by 1, 0, 1 is equal to 1, 0 with the rest of 1, 1. And this is equal to 2 in base 10 with rest of 3 in base 10, which you'll see is the same result. I suggest you do some examples just to get some practice on this, as it's very useful. Now, coming to some pitfalls. So the first one I want to talk about is misalignment. The problem that occurs sometimes, which has occurred to me sometimes before, is that you accidentally write these numbers in the wrong position. So here you see the multiplication of these two numbers, and what should have happened is that this number here is positioned here, and this number here is positioned here. Now, for the second number, it's not as important because it's just zeros. However, here it makes a difference because we add these two ones, for example, even though they should not be aligned with each other. So the result you get here would be 0, 1, 0, 1. So this is the result you would get, and you would also, well, depending on how you align it, have different zeros, which is another problem. But in the actual solution is this number. And these are wildly different numbers, and for this reason you have to watch out for alignment. The same is true for aligning with division. That you pull this number down, that you pay attention to how many values you have here, so you line them up here. So instead of lining them up here, you want to line them up here, so you don't make a mistake. And that's why I recommend always writing out the zeros, like here, so you don't skip the alignment. So for example, if I wrote this number here, or rather added this line without this one being here, I might have written it starting here. So that's why I recommend always writing zero lines, even when they're not contributing anything. Another issue that can arise is a bit overflow. Now this happens when you have a multiplication of numbers which have a certain number of bits. So in this case, both of these numbers would have 4 bits. And if you do this multiplication, the result is not necessarily going to have 4 bits. In this case, the result has 7 bits. And in computers, the number of bits is usually static. And this means that the number of bits in the output cannot be changed from 4 to 7 if at the beginning it was defined as being 4. For this reason, if you have two numbers with an amount of bits, you have to make sure that you have enough bits in the output to actually carry this multiplication. If this would not be the case, so if we only had 4 bits to represent this, what would happen is we would only see these numbers here. These numbers up here would disappear and our result would be invalid. For this reason, it's important to realize that in multiplication as well as division, these things can happen. To quickly recap, binary multiplication is all about shifting and adding, and division is just about smart subtraction with shifts. Watch out for misalignment and overflow, and you'll be good to go. If you enjoyed this video, you will enjoy my other video on how negative numbers are represented in computers. Also consider subscribing for more computer science content, and if there are any topics that you find confusing or have difficulties with, write a comment about it and I might make a video on it in the future. Thanks for watching.